What's the lines for? The lines is for what? Why you can connect all these 3 points? Little question. How to draw a vector? The symbol of a vector. It is combined by a line and an arrow, right? A line and an arrow to represent the vector. Like this. A line and an arrow. That is a vector. So I don't see any arrow in your drawing. Okay, first, could you please tell me where is the vector A? How to draw where to put the line and the arrow? Yes, the line and the arrow, where do you put it? The line and the arrow represent the vector. Where do you want to put it? Okay. Go ahead. You can do it. Okay, we'll come here and help. Take a
This one is y-axis. This one is y-axis.
yes.
And then we become this is the.
But yeah, that is the right. The final is correct.
And then to present the vector because this one is complex. This one is complex. This one will give like
good. That is a vector A. And then how about vector B?
Vector B will be
yes, it is good. I minus this. I minus 1 I minus 2. Positive 1. Yeah. Vector B.
It will be here.
so
Yes.
and then 4. That
Right.
so is the time 1 and there is 1. 1 is this one and negative 1 is equal to this value. It's one and negative one.
Yeah. Make it short. Right?
And then negative 4.
Yeah.
And negative 6.
Yeah.
Negative 4 we are having is here.
Yeah.
And negative 6 is in this side. It's not that to be
And then C.
here it's C. Here it's B.
Yeah.
Here it's A.
Right? And you have drawn the three vectors, right?
Because you see is the end of the phone.
Why you provide this report? What was this line arrow for?
I think there's a number of drawing there. Like if I think A vector, this is A vector,
Yes.
this is B vector,
Yes.
and this is D vector.
Yes.
I think that
Good. Then you have two. What is one? The first one, you got a final answer correct. That is a 0i and 0j. That is correct. And the three vectors you draw here is both or correct. And there is one question. If you have drawn the three vectors, then you can see it here. And then you know the final result of the superposition of these two vectors equals to 0. How can you tell why these three vectors, the addition of these three vectors equals to 0? How can you be equal to 0?
I can say
Yes.
here is 0.
What does it mean if these three vectors, the superposition of these three vectors equals to 0? What does that mean? Why the addition of these three vectors, or we can see it is there here. Why the superposition of these three vectors equals to 0? What does that mean?
Means that
Okay. First, thanks the first students for the correct coordinate system and for the correct 3 points. Then, thanks for the second one for the correct calculation and the draw. And you can see there are 3 vectors. And then if we know the superposition of it is 0, what does that mean? Why is 3 vectors equals to 0? First, if I draw A here, 3, 4, and there is a B, that is correct. And if a vector is I minus j, which means only the movement or the difference between its starting point and the ending point. So the B can be here, it is correct. Or it can be anywhere, for example, at this point to this point. That is also a I minus j. That is correct too. So we can move this B to the end point of A like this. J. That is a B2. Then, how about the C? Minus 4I and minus 3J. Minus 4I and a minus 3J. So we can move this vector to this position. Then we result in an interesting triangle. A, B, C. And they started at point 0 and finally ended at 0.2. That is the superposition of vectors. If we only take the values into consideration, we can never get an answer like this. So that is similar to the way we calculate the electric field. Take the I and J into consideration. Otherwise,
The reason why you have chosen a vector, the reason why you have chosen a vector as superposition.
yes, that is why we use the superposition of vectors.
Because it has a high number of 3 and 4. It has real numbers.
3 and 4. Yeah,
That is why I have chosen it. Because others has negative.
I think he chose it because it's easy to understand.
Sorry, but I don't understand.
You know, first three you have found.
Yeah, 0 point.
0 point.
Yes.
As 0, 9, and 0 here. Then you have.
Yes.
And after that, after pointing on the A vector, B vector, C vector, you need to find superposition. And then you find it comes out that chosen this line to find superposition. I'm wondering if this 3 and 4 is the reason why you have chosen this 3 and 4.
Why
As
is this
superposition.
so?
As superposition, because they have big number, not big number, than this one and this one. Because I think that we have chosen this one and this one because they have big number than this one and this one.
No matter about.
You can even use this one.
Yeah, of course.
But if you can make
Another example, when you like a small line and a bigger one, and bigger one. So it's okay. The result of the superposition of 3 vectors equals to 0, 2. So no matter the number.
you can even use this one.
Yeah.
So Laushi means that you can have this, can even have a solution B, can even have this one or you can just every BI.
Yes, that is all correct. You can do it. Like this. Correct. So, in doing the superposition of vectors, take the direction into consideration. That is the only thing you should remember to do it. So, up to now, how to calculate the electric field around point charge have been finished. No matter how many point charges are there, no matter how. no matter how many it is. We can do it. We can do it. Just follow the steps. First, send a coordinate system. Then, do the calculation of the electric field one by one. And finally, take the direction into consideration. Then, we got the answer. If the point charge, the electric field around the point charge can be calculated. And in our life, point charge is hard to see. What is more common is a charge thing with shape and with volume. For example, a charge line or a charge plane or a charge volume. There's one dimension, two dimension, and three dimensions. The electric field around line or surface or volume can we do the calculation? Or how we do the calculation? Then there is a new definition of charge density. For a line, if the overall charge amount is a large Q, which means the charge is uniformly distributed along a line. So if we cut it into two pieces, the upper one there's a half Q, and the lower one is a half Q too. If we take it into a more smaller one, we cut it into numerous pieces. We take D, L here, which means a little pieces in this line with a very little length, dl times lambda equals dq, and the lambda is the charge density. And small pieces of the line times the charge density equals to the charge in these little pieces, like how we calculate the matter density for materials is similar. For this, if the dl equals to, for example, half L, the half L times lambda should equals to half Q. If the dl equals to, for example, 3 L over 3, the resulted D charge, the quantity of charge should be Q over 3. So we can do the calculation actually. The lambda equals to Q up L. And the Q is the overall charge. The L is the length of this line. So for charge line, is lambda equals to Q over L. L is the length of it, and the Q is the overall charge. Then, for a surface with a random shape, theta, charge density, equals to Q over the area of it, and then we can analyze yes. For volume, rho equals to Q over the value of it, and then we can analyze Q over V. Volume, area, yes. If the charge density is defined, the calculation is the integral covers the whole system of charge particles. Integral covers or the overall charge particles. Begin from a simple one, a charge 1. It is Q charge. And the Q is distributed uniformly along the line with length 2A. 2A. Lying along the y-axis between y equals to minus A and A. Y, X, and A minus A. Find the electric field at point P on the x-axis at a distance h from the origin. X. The electric field at this point. Let's do calculation one by one. Like center coordinate system down. And do the calculation of electric field one by one. Is the process 2. If it is known, we begin from a little pieces of this line. For example, at the top of this line, the dq in a very little pieces of it equals to lambda dy. Cos the lambda is the charge density of a line, and the charge density times the distance of the line equals to the quantity of charge in these little pieces. If it equals to lambda dy, the lambda we already know equals to Q equals to L. In this situation, the L of this line equals to 2A. So lambda equals to Q up 2A. Then here. I will check the attendance. Yes. No? Attendance, no.
No, nothing.
Or why late for such a long time?
So I don't.
No, I just want to know the reason.
I was late in Rome.
Huh?
I was having something else.
But you were late for too long. So tell me your name out here.
Ayub, the 11.
11?
Yeah.
Well, for late, okay? You attended for late. And the DQ is known. The electric field given by this DQ can be calculated using the equation we already know, and that is dq up 4 pi epsilon 0 r squared, no matter. However, the r is an unknown one. We don't know the distance between these little pieces to the point x. What we know is only the x and the y. And the x, y is known, the r can be calculated as r equals to x squared plus y squared and the square root of it. The dE can be write like dq 4 pi epsilon 0 r squared. Then take the dq represented by q divided to a, and then the final equals to q dy 4 pi epsilon 0 x squared y squared and 2a, like here. It is positive charge. So the electric field at this position given by these little pieces has a direction, and the direction is point from these pieces to the direction of far away from it. If the direction is neither parallel to the x-axis and parallel to the y-axis, so we should take these two directions into consideration at the same time. The first one is the part of it parallel to the x-axis and the part of it parallel to the y-axis. The first one parallel to the x-axis, we can take the theta into consideration, and Ex will equals to E times sine theta, and the Ey equals to E cosine theta. That's correct. Let's equals cosine. He takes this. So
AX, I think it can be cosine.
sorry. Again, please.
Yeah, that's what I was saying.
Okay. So let's take this angle. No, not this one. Sorry for that. And then cosine theta. cosine theta or the sine theta can be represented by x and y. So then we do the replacement of the cosine theta and the sine theta into the xy. And the final result is shown here. dEx equals to this one part, and the dy equals to this one. No matter how complex it is began from here. Just 2 times another cosine theta and the sine theta. And the cosine theta and the sine theta can be represented by these 2 things respectively. And then the final thing is to do the integral sines. The dE is known. dE is known, which means the electric field given by this little pieces at the point x can be represented by the x and y and q and 2a. The only variation parameter in this equation, there's only one parameter that is variation, and that is y. Why? Because no matter at the point x, so the point is a constant one, x is constant, 2a is the constant, 4 pi epsilon 0 is the constant, and the q is the constant. The only one that varies is the y, and the y is vary from minus a to a. So when we do the integral of this equation, we just take it, the integral of dy, and then from minus a to a. The calculation of this integral is a little difficult, and I have no time for this calculation here. That should be taught in your math class. So here I just show you the final answer. And the final answer of dx equals to q or pi epsilon 0 x. In this equation, no matter the 4 pi epsilon 0 or the large Q or the x and the a, all the parameters in this equation is all constant because the Q is given by the question, and the x is given by the question, and the a is given by the question. So this it seems complex, however, that is a constant. So the dx is known by this equation, and the final uy equals to 0. Uy equals to 0 means at the point x, the electric field due to this charged line in the direction parallel to the y-axis equals to 0. So there is only one direction in this point has the electric field, and that direction is parallel to the x-axis. So finally, no matter how complex the calculation way, the final electric field at this point, given by the charged line, is parallel to the x-axis, and it is a positive one, so it is a point to the right. It's E and equals to if there's a solution, the A or the length of the line is infinite. It is a super long line, which means the A is much larger than the X. So in this equation, if the A is much larger than the X, the X squared of the A squared will seem to 0 when the A much larger than the X. So up the fraction here, this part will close to 0. So finally, we got an answer here. The electric field with a distance x along from an infinite charged line. The electric field due to this infinite line equals to lambda up to 5 epsilon 0 r. Number, charge density, 2 pi epsilon 0, all constant, and the r is the distance of the point away from the line. Hey. Yeah.
So the first answer we got when we were calculating
Hey.
distance x.
Yeah.
So it doesn't matter the distance of A or x. Is that the equation that always
You can replace it by x. It is okay.
Oh.
That's because we always use the r as the distance away from something. So if the x is only used in this example, so I replace the x by r. So that is the same term. If you can't remember how to do the integral of the calculation, just remember the result that will be used in your final exam. If you don't know how to obtain this result, it is okay. Have a remember and make sure you clear off any parameter in this equation. Number r 2 pi epsilon 0 in E. The content we should learn today is finished. Maybe little homework. Okay, no homework for today. But please, after school, have a look of this example in the PowerPoint I have given to you. This example, it is very useful. If you know how to calculate, and if you make sure you understand this question, and make sure you can finish, you can handle the question will be included in your final exam. So to review this question after the class. Okay, class is over.